Good morning, students. So we'll start solving the problems over DFA. So actually, DFA consists of total three types of problem. The first one is pattern recognition problem, then divisible by K problem, then mod K problems. Okay. So here, in case of mod K problem, we are having different varieties also. Okay. So we'll discuss about that later. So first we'll begin with pattern recognition problem. Okay. So we'll solve around 15 to 20 different problems over pattern recognition. Okay. Then we'll go for divisible by K and mod K problems. Okay, fine. So now you got a question, the first one. Draw a DFA to accept string consisting of at least one A. Observe it carefully. You need to draw a DFA for a string which consists of at least one A. Okay. So before we move on to solving this question, okay. So first we'll consider what exactly the string pattern we may encounter for this question. Okay. So the number of alphabets which is residing in this particular question is what? Means the sigma is only equal to A exactly, because apart from A, we are not expecting any other alphabets over here. Okay. Like B or else C, okay, such kind of alphabets is not available in this question exactly. Okay. So the alphabet we need to utilize is what? Only A exactly. And the string, what we are expecting is it must consist of only, at least, sorry, not only, at least one A. Okay. If it is followed by a series of A, then we don't have any issue. Okay. But epsilon should not be available. Clear? Epsilon should not be available. That is what it is stating. Observe it carefully. Okay. String consisting of at least one A. Minimum one A must be available. Okay. Then the DFA should accept this particular string. Fine. And if your input string is like triple A or double A or 4 A's or 5 A's, okay, then also it must be accepted. Clear? Got some idea? Like what should be the input string for this particular DFA? Fine. You need to decide this. Okay, before we solve the question, we must have some clear picture about what are these possible string. Okay, we can generate from this particular question. Okay. So now, from previous session, okay, we had a note like if you are having a minimum string like AB, okay, so this is what the minimum string what I want to make my DFA to accept. Okay, so how many number of alphabets are available, or how many? What is the length of this particular string exactly? Just observe. Instead of mentioning like number of alphabets, I would like to mention like length of this particular string. Okay, what it is? 2, right? Okay, so we are considering this 2 as n. Okay, the length is equal to 2 and 2 I am considering it as n. If I want to solve or if I want to design a DFA for this particular string, then I need n plus 1 state. Remember this. Then I need n plus 1 state exactly. Okay, so 2 is the length of the particular string. Okay, minimum string. Okay, it is not compulsory like only 2 should be the length of a particular string. Okay, the minimum string we are expecting is 2. Okay, then n plus 1 will be the total number of states we may need in designing the DFA. Okay, so 3 states we need. Okay, so here in this question, what is the minimum string we are expecting? Observe it. Minimum is what? Single A. Maximum any number of A it may be, does not matter. Minimum is single A. Okay, so if I consider the length of a single A, what we are getting? Length of single A will be, sorry, wait a second. Okay, length of single A will be what? 1 exactly. Is it? Okay, so n has become 1 now. 1 plus 1 will be what? Equal to 2 exactly. Means we need total 2 states to solve this particular question. Okay, fine. So we'll see that. What are those states? So according to our previous knowledge or previous session knowledge, okay, so we got to know like, okay, fine. To solve this question, we need 2 states. That is, first one we are calling it as Q0 and second one we are calling it as Q1. Okay, you need to begin with Q0 itself. Okay, don't begin with Q1, Q2, Q3 and all. Okay, later you will get confused. Okay, because in every problem we are considering Q0 as a start state. Okay, while writing the transition diagram or transition table, okay, you may get confused and you may do some mistakes over there. Okay, for while renaming or while naming the states over there. So better start from Q0 itself. Okay, so Q0 and Q1 we got. So out of these two states, one should be made as a final. Sorry, one should be made as a start state initially. So I will make this Q0 as a start state. Okay, what is the gesture of the start state? Okay, a label arrow mark with start. Okay, so this is what the gesture of a start state. Okay, fine. So let me take an example. Fine. Okay, so single A, later double A, later triple A. Okay, so instead of checking the DFA for only for single A, okay, we need to check for some other string pattern also, single A, double A and triple A. Okay, so if you want, you can go for multiple number of A's also. Okay, so total 5 A's we got over here. Fine, so these are the 4 example I would like to take it for this particular DFA. Clear? Okay, so what we did, we took some examples, okay, or samples of this string, okay, which is satisfying this condition. Okay, then I'm going to take a 2 states, that is Q0 and Q1. I made Q0 as start state. Okay, fine. So now if this string is of this pattern, okay, only one A we are having. Fine, if I provide it as the input for this Q0, okay, remember, okay, if I make it as input for the Q0, okay, I'm writing it as here. On receiving A in Q0, Q0 will change the state from Q0 to Q1. Q0 will change its state from Q0 to Q1. Why? Because we need to move towards a final state. Remember this. Okay, we are having a 2 states. Okay, one we are making it as a initial, like for start state, and one it should be made as a final state over there. See, now Q0 is a start state. If a machine changes state from Q0 to Q1 on receiving A, okay, then if I make Q1 as a final state, observe it carefully. If I make a Q1 as a final state, if we have a string of this pattern, it will be accepted. Is it right? Huh? If you are having a single A, see here, Q0 on receiving that single A, Q0 is consuming that A and it will change its state from Q0 to Q1. Okay, Q1 we are making it as a final state, then obviously this string will be accepted. Condition satisfied. Clear? Now what we need to do? We need to check for other string also. Observe it carefully. Double A if we are having. See, first A, clear? First A will be consumed by Q0, right? It will change its state from Q0 to Q1. Okay, fine. Then what about the second A? Do we have any transition from Q1? Okay, see here, there may be possibilities of 2 transitions like this. Okay, A, or else it may be going to Q2 sometimes. Okay, so these are the possibilities. Okay, what we may face in other questions and all. But in this question, okay, in this question, we don't have such facility. Okay, we are having minimum string A. We got only 2 states. Okay, one we are making it as a start state, and one we need to make it as final state over here. Now, how to process this second A? See here, if I provide a self loop for see here, if I provide a self loop for Q1 for an input alphabet called as A, then second one will be accepted. Is it right? See, first A will be consumed by Q0, right? It will change its state from Q0 to Q1. Now you are in final state. Okay, so now second A will be consumed by Q1 itself. Okay, second A will be consumed by Q1 itself because we are having a self loop. Okay, you may ask why we cannot provide it for Q0. Okay, backside. Okay, or else say forward one. Okay, like how I did like before I erased that last transition diagram. Okay, is it? See, we had one transition from Q1 to Q0. See, if that is the case, okay, double A if you are having for processing first A, Q0 will change its state from Q0 to Q1. Okay, fine. You are in final state. Now, after processing the second input alphabet, you will be in Q0. Okay, double A will not be accepted by this DFA. Wrong, it will be. Okay, so according to the condition of accept and reject. Okay, according to the condition of accept and reject, what we have. Okay, when it will be accepted, when you will be left with epsilon, and if you are in a final state, okay, then it will be accepted. Okay, and if you are left in epsilon, and if you are in non-final state, okay, non-final state, then it will be rejected. See, in second case, okay, instead of providing this self loop, if I make it as reverse loop for q naught, okay, if you are having double a, first a will be from q naught to q1, okay, second will be q1 to q naught. Where you are standing now, you will be in q naught, okay, double a will be rejected exactly, right? This should not happen, remember. Okay, this should not happen. So self loop, if I provide it for q1, okay, then double a will be accepted. Then we'll see here. So this is what the benefit of taking multiple examples, okay, to check whether this DFA is holding good for all the varieties of this condition or what. Okay, so single a, yes, it was accepted, okay, but double a, see, we need to make some changes for this particular DFA over there. Now we'll see this triple a. See, first a, you are coming for q0 q1, second a, you will be in q1, third a, you will be in q1. Self loop it is. Means after consuming 1a by q naught, after changing its state to q1, okay, how many number of a you may get, you will be remaining in q1 itself, and finally it will be accepted. Okay, means this, okay, fine, we'll go for the one more example, that is continuous 5 a's. So first a, second a, third a, fourth a, and fifth a. Okay, when you are reaching the final state, and when you are reaching the end of the string epsilon, okay, you will be in final state. So this is what the DFA, which is accepting the all possible conditions of this question. Clear? Okay, okay, fine. So this is what the skeleton, what we can draw for this particular question. Okay, so apart from this, what we need to do, we need to write, what next, we need to write machine. Okay, what is that? M will be equal to q comma sigma comma delta comma q naught comma f. Okay, so these are the what, the components of the DFA. So these components should be identified by this particular skeleton exactly. Now we'll see this. What does q stand for? Q will be equal to, yes, q will be equal to what, the number of states, or list of state will be represented by q exactly. So what are those? Q naught, okay, comma q1. Fine. So these are the two states what we can identify from q exactly. Then what about the sigma? Sigma stand for what? The input alphabet. The input alphabet. What are the alphabets we are using? Only A. Okay, apart from A, we don't have any other alphabet. So A it will be. Clear? Then later, sigma over, then delta I will write it later. Okay, after writing the start state and final state. Okay, so Q naught is the start state, right? Q naught is the start. Okay, then later, final state f will be equal to what? F is equal to q1, is it? F is equal to q1, obvious. Okay, see here, q1 is the final state, so f will be equal to q1. Then later, delta we are having, right? Okay, what does this delta stand for? Delta is a transition function. Okay, so whatever the transition we have for q0 and q1, okay, on receiving alphabet a, okay, that should be mentioned. Okay, so how many possible transitions are available in that particular state, that should be defined. Okay, so we'll see this delta of, okay, so delta of q0 comma a, okay, will be equal to what? Q1. Is it right? See here, delta of q0 means transition function of q0 on receiving a, it is changing its state from q0 to q1. That's why I'm writing like this. Then later, the second one, delta of q1 on receiving a will be equal to what? Q1 itself, right? See, q1 on receiving a, it will be remaining in q1 itself. Fine. So like that, in further problem for particular state, we may be having different transition, one for a, one for b, one for c. Then we need to go for providing transition function for each and every transition. Remember, okay, it may be for a, b, c. Okay, all three should be mentioned over there. But in this question, we are having single transition from each state. So single transition we are writing over here. Okay, so this is what a complete answer for this particular question. So apart from this, okay, we can write the transition table also. Okay, transition table also. See here what we are to write. Remember, delta we need to write, and here in the column we need to represent the input alphabet. We need to represent the input alphabet. What is the input alphabet? A exactly. Then here the states Q0, then Q1. Okay. So now how to read this? Delta of Q0 comma A. Delta of Q0 comma A. This is how we are reading. Okay. Delta of Q0 comma A. How to write? Don't refer this. Okay. You can directly refer the skeleton. Okay. Because sometimes, okay, you may do mistake in writing this kind of function. Okay. So that can be rectified by transition table. Okay. You can cross verify it later. Clear? Okay. So better you refer the skeleton itself to update the transition table. Okay. So delta of Q0 comma A, delta of Q0 comma A, where you are going? Q1, right? So Q1 should be updated over here. Then delta of Q1 comma A, delta of Q1 comma A, where you are going? Q1 itself. Okay. If you are finding like there is no transition for one particular like alphabet. Okay. Example, like if you are having A comma B. Okay. So in Q0 also you don't have a transition for B, and in Q1 also you don't have a transition for B exactly. So in that case, how we can do? See, B we can write. Okay. Just an example I'm taking. So null. Okay. Means this dash represent there is no transition for delta Q0 comma B, delta Q1 comma B exactly. Okay. But in this condition, we don't have such option. Okay. We are having only one alphabet. Okay. And two transition. Okay. Now after drawing this, okay, you can verify delta of Q0 comma A, delta of Q0 comma A, Q1 we are writing. Then same we got delta of Q1 comma A. Okay. Q1 we are writing. Same we are. Okay. This is perfectly all right. Okay. So this is what the first question.